This is our group member. Our group consists of 4 members, namely is AIMAN SAIFULLAH bin AMAT, AIMAN NASHRIQ bin AZHARI, NURFATIHAH Adriana ABDUL AZIZ, and our group leader, Michael DARREN, ANAK David LUNS. For introduction, sequence, and address, me and SAIFULLAH will explain it. For electrical diagram and electropneumatic, AIMAN NASHRIQ will explain. And then for ladder diagram, Michael will explain for MMP 201, and then Teha will explain ladder diagram for MMP 202. And then for HMI, Teha will explain. And then for our group demonstration, Michael Darren will explain the sequence and demonstrate the project. And then last but not least, Teha will explain for our group conclusion. Okay, my name is AIMAN SAIFULLAH. I'm going to explain our group introduction. MMP is Advanced Geographic Information System GIS software that revolutionizes mapping capabilities by offering comprehensive tools for spatial analysis and visualization. MMP stands out for user-friendly interface, facilities efficient data manipulation, and allowing professionals to create detailed, accurate maps that tailor to specific needs with ease. MAP 200 provides a robust array of features that enable users to integrate various data sources seamlessly, empowers them to generate insightful spatial representation, and make informed decisions across diverse industries and sectors. Okay, this is our addressing table for NAP 201. For input, we got 7 input. Stand for start button, stop button, auto main selector, feeder backward, feeder forward, transfer cylinder forward, and verification cylinder downward. For output, we got 4 output, stand for A+, B+, C+, and D+. Okay, start button, the address is 0.00. Stop button, the address is 0.01. For auto main selector is 0.02. Feeder backward 0.03. Feeder forward 0.04. Transfer cylinder forward 0.05. Verification cylinder downward, the addressing is 0.06. Okay, for output is the address for A+ is 10.00. For B+ is 10.01, and then C+ is 10.02, and then the last one is D+. The address for D+ is 10.03. Okay, this is our addressing table for MAP 202. For input, we got 8 input, and then for output, we got 6 output. The input stand for start button, stop button, main selector, manipulator backward, manipulator forward, manipulator upward, manipulator downward. And then for output, we got A+, A-, B+, V, lamp, and buzzer. For address, start button is 0.00, stop button is 0.01, main selector is 0.02, manipulator backward is 0.03, manipulator forward is 0.04, manipulator upward is 0.05, manipulator downward is 0.06, and then the vacuum is 0.07. For output is we got A+, the address is 10.00, and then A- is 10.01. For B+ is 10.02, and then the vacuum is V 10.03, and then the LED is 10.04, and then lastly is buzzer The addressing for buzzer is 10.07. Okay, this is the sequence for MEP 201. The sequence is PB1, A plus, C plus, C minus, A minus, B plus, B minus, D plus, D minus. It will move like the original program without stopping. But if there is damage or error that happened to the object 3 times, the machine will stop immediately. If a correct body position is detected, it will be excluded from the system count. This is the sequence for MAP 202. The sequence is PB1, B plus, V plus, B minus, A plus, B plus, V minus, B minus, A minus, and then off. Okay, it will move like the original program, but if the object is absent, the LED and buzzer will be for 5 times, and then the program will reset. Okay, that's all.
Assalamualaikum. My name is AIMAN bin AZHARI, and I will explain my two parts. That is the electrical diagram for MEP 201 system and the electropneumatic diagram for MEP 202 system. First, I will explain the electrical diagram for MEP 201 about the input, output, and the graph set that we made from the software called Festo FluSim. The MEP 201 has 4 outputs, 3 of them using a double action cylinder and another using a single action, and the directional valve for each cylinder using a 5-way valve. The inputs has 5 inputs, that is push button A1, A0, B1, and C1. The graph set of the MEP 201 that we made from the question given. There are 2 types, the incorrect position and the correct position. The incorrect position will start from the initial step 0 until step 8. If the machine detected a correct position, it will start over from the initial step 0 and continue to step 9 until step 14, and it will repeat 3 times. Thank you. After that, I will explain the electropneumatic for the MEP 202 system that has 5 outputs: buzzer, LED, A plus, B plus, and V. V considered as a vacuum. Three of them use a double action cylinder and the directional valve for each cylinder using a 5-way valve. The input has 6 inputs: push button, A0, A1, B0, B1, and V1. The graph set that we made from the question given, there are 2 types, the detected object and the undetected object. When the machine starts from the initial step 0 and detects the object, will continue until step 8 and will repeat when we push the button. If the object is undetected, the buzzer and the LED will turn on for a second. The initial step 0 will continue to step 9 when the object is undetected. Thank you.
As this is the ladder diagram for MMP 201. For MMP 201, it will have 14 steps. So it has 2 sets of steps, which is for incorrect position of the product and the correct position of the product. For the incorrect position, it will start from step 1 action. After pressing PB1, it will extend the cylinder cylinder A, and then after cylinder A has been extended, step 2 will be executed. Step 2 executed, the cylinder C will be extended. After cylinder C extended, it will also activate timer 005 for 3 seconds. After that, cylinder C will retract and it will activate timer 001 for 3 seconds. After that, it will retract cylinder A. After retracting cylinder A, cylinder B will extend. After cylinder B extend, it will delay for 3 seconds. Then it will retract. After it's retract, the cylinder D will extend. and then it will activate timer for 3 seconds, then it will retract. That is for the correct position. As for the incorrect position, the product has been placed in the incorrect position, when pressing push button 1, it will extend cylinder A. After extending cylinder A, the product cylinder C will extend, and then it will active timer 005 for 3 seconds, and then it will detect the body is in the incorrect position, and then the cylinder C will retract, and then cylinder A will also retract. After that, step 11, cylinder B will extend, and then after it's extend for 3 seconds, after the timer has been activated, then cylinder B will retract. Step 13, for cylinder cylinder D, it will extend and then 3 seconds. Then for step 14, it will retract cylinder D. After the incorrect position has been detected, or incorrect position sequence has been finished, then the counter will count the incorrect body position, set the counter 1. So from 3, it will count 3 times for the incorrect position. So the counter, if it doesn't detect incorrect position sequence when it's finished, it will does not include in the counter. So after it has been counting for the incorrect sequence position for 3 times, then the system will off. If not, it will repeat until it has fulfilled 3 times of the sequence. Okay.
For MAP 202, now I will tell you how the program works. Press the push button, cylinder B will extend. Then A will trigger to detect the object. Cylinder B will retract. Cylinder A will extend. After that, cylinder B will extend. Then timer will trigger for 3 seconds to let cylinder B retract. After that, it shows that the object is detected. While if the object is not detected, after press the push button, cylinder B will extend. Then sensor V will trigger. Then he detect that there has no object. The alarm will blink for 5 seconds to show that has no object has detected. After that, the program will be restart. We design using NB Designer. Firstly, we connect screen display to Omron PLC. For MAP 201, it has bit button as push button, which is PB1. We also put 4-bit lamp as sensor and also 4-bit lamp as cylinder extend. And also 1-bit lamp as counter to count each sequence. While for MAP 201, we have 1 buzzer, 4 cylinder, which is cylinder A, retract and extend, 1 for cylinder B for extend, and 1 for V for A trigger. Also 5 sensor.
This is MAP 201 with HMI interface. So when pressing push button 1, the machine will act according to the sequence. It will extend the product, and then cylinder C will check if the product is in the correct or incorrect position. When it is in the correct position, the counter will not count. It will exclude the count. If the cylinder C detects the product is in incorrect position, it will count in the counter. The counter will count down from 3 to 2 and from 2 to 1. If the checking of this machine will repeat until it's fulfilled 3 times of the counter. When it is fulfilled, it will stop the machine. So from the counter is 3, 2, 1 until 0, it will stop the system. To restart the system again, just press push button 1. It will reset the counter and the machine will repeat the step all over again until it's fulfilled the system requirement. Okay, that's it. This is the demonstration for MAP202. When pressing push button 1, the machine will detect if there's an object at position A. If there's an object at position A, it will take the object to position B, and then the machine will go back to its original position. When pressing the push button again, if the machine does not detect any object at position A, it will sound the buzzer for 5 times and clip the LED for 5 times simultaneously.
Firstly, it will demonstrate the team's ability to understand and identify the sequence function of a specific station, as well as identify the sensor used in the station. Additionally, the project will showcase the team's understanding of designing graph set models based on the default sequence function of the station and designing a PLC using a suitable IEC 611313 standard programming language controller. The project will highlight the team's comprehension of dividing a complex system equivalent hardware and software modules and programming individual modules with library capability. Lastly, the project helped us to showcase the team's capability to implement a communication interface to the higher level control unit. That's all from us. Thank you.